Okay, welcome to another episode of Vlogging with Log. I thought today we'd talk about the energy that's in food. And all the energy that's in food, we actually refer to it like chemically as thermal energy, which is just really fancy for literally its heat, which is really weird because if you're sitting here eating chips, like I just did, chips aren't hot, but the energy, that calorie that's on the food label is just a measure of how much heat is in it. Heat is a type of energy. Um, and so that's interesting. So you can't ever just like stick a thermometer into a chip and figure out how much energy is in it. What we're able to measure is heat transfer. And so that energy reading that's on the food is just a measure of the transfer of heat from the food to you, which is weird. Weird. There are a few different units that we use to measure energy. The very first one is joules, and it's not spelled like jewelry or anything. And you'll see it represented with a capital J or sometimes KJ, which would be my rap name. Kilojoules, it's metric. um, Again, in every 1 kilojoule, that's equal to 1,000 joules of energy. And that's usually the unit that we see. Here in the United States, though, we don't use joules. We make things really confusing because we use a lowercase calorie and a capital C calorie. This is our dietary calorie. That's what we see on the food labels. This is used in any sort of chemistry as a measure of energy, and this is because there's a ton of energy in food, and the metric system would scare people, so they don't say kilocalorie here in the United States. They just gave it a capital C to make it seem like, whoa, it's big. Um, but over here I have the conversion. And where they actually got this number is that 1 calorie is the amount of energy you have to add to 1 gram of water to change its temperature 1 degree. So if I wanted over in Europe to heat up 1 gram of water 1 degree Celsius, I would have to add 4.18 joules of energy. That's where that comes from. So if you are eating something that has 1 calorie in it, it's got enough energy in it to heat up 1,000 grams of water 1 degree Celsius. That's crazy. It's super weird to think about, but it's awesome. And so, like I said, over in the rest of the world, they don't list that calories. Notice their energy is actually labeled and it's got that kilojoules on there. So I think that's kind of interesting. If you're ever lucky enough to go and travel, just check that out. I thought it'd be fun to do a little bit of revisiting on how to convert between units. So this is where you need the conversions that we just had before. And this is where we're going to follow the same steps as we take the number, put it over 1. We're going to turn it into kilojoules. There are 1,000 joules in 1 kilojoule, and I end up getting 4.8. I'm not going to stress over sig figs. But the next one, where we're going from calories, the little calories, to joules, and put that over 1. In 1 calorie, there's 4.18 joules of energy. So for my answer, I ended up getting 353,724 joules. I'm going to skip the last one, but you might see some using both. Let's try this one, Chipotle. I might eat that for dinner. That sounds awesome. The burrito, really fascinating. If you're just curious, go to chipotle.com and underneath their nutrition, you can like type in everything you order. My specific burrito that I get, there's my order, is 975 calories. One day I had 3. Hell yeah. So let's take that and figure out how many joules of energy I have. So 975 calories. I'm gonna put this over 1. Oh, get over 1. In 1 big C calorie that's on a food label, there's 1,000 little calories. And then in 1 little calorie, there's 4.18 joules of energy. So if this were to show up on a food label somewhere across the globe, I take in 4,080,000 joules of energy when I have my Chipotle. I did the math, and in order for me to fuel a marathon, I would need to eat 2-ish burritos. So just FYI. Don't ever do that before you run. You will puke. And actually, I will never do that. I don't know if that's on any of your bucket lists, but that has never been on one of mine. So, what's crazy is that with the food you eat, your body breaks it down into those amino acids, and your blood helps to take off or take some of the food as glucose, which is C6H12O6, carbohydrate, and it reacts it with oxygen. So, this is what your body's doing with your breakfast that you ate right now. And the products that are formed are CO2 and H2O. What type of reaction is this? It's combustion. I didn't balance it because I'm too lazy. But in a combustion reaction, the other product is a whole lot of heat. This is why you're hot right now. Because all your cells are combusting right now. Like, it's happening. You can't even control it. And so no matter what anybody ever says, hell yeah, you're hot. Cellular respiration. Anyway, those ringed carbohydrates, they take up a lot of room. If you got about a gram of that, that's equal to about 4 of the big C calories. 1 gram of protein is also equal to about 4 of the big C calories. And fats are really awesome storage molecules. If we stored everything as carbohydrates on our bodies, we'd all be triple the size that we are right now. So this is just a really awesome molecule, really energy rich. So that's awesome that we store things that way. If you work at like a food company, I know we have General Mills here, or if you worked at like Dairy Queen in their corporate, McDonald's in their corporate, what they do is they take out all of the protein and all of the fat and all of the carbohydrates, which is what we would have done in class. Look at the grams of that, and that's exactly how they figure out the calorie content of the food. So in class, we would have talked a little bit more about that. If you were Michael Phelps training for the Olympics, this was kind of his average day. I feel like I could do it. Like, I feel like one of you needs to cook all this and call me, and I'll come over and we could do like a YouTube challenge video or something. I think I could do it. I'm trying to think. There was one. I mean, I for sure, like, I feel like all that breakfast food I would totally eat. I mean, look at it, like the pasta, buddy. I mean, I could do it. Probably not go to the Olympics, but. So here's the equation. They picked the letter Q, which is kind of annoying because it's energy is what that is. This is the equation they use for it. They take the mass of, this is usually the mass of water. Oh, I have the substance being heated, which is usually water. And they multiply it. I have C here. It's a constant, and that constant is 4.18, and I'm going to write joules per gram Celsius times delta T, which is the change in temp. And this has nothing to do with gases, so you don't have to worry about Kelvin. So what they do, literally, if you work for General Mills or Taco Bell in any of the corporate facilities that they have, is since our bodies actually burn the food, to figure out the calorie content that the food has, they light the food on fire and heat up water with that flame and measure the temperature change of the water, because you can't stick a thermometer in the flame. So like my Butterfinger Blizzard that I like to eat, they dehydrate it, take out all of the water out of it, and they light that on fire, and they measure how much heat transfers to water, and they calculate that. I know, I feel like I could work there and do that. So let's say you had a Big Mac, okay? So here's our equation, or Q, or energy, mass C delta T. So if I bought a Big Mac, which is about this many calories, that has that much energy in it, and I lit it on fire. Yep, burn, baby. And I used it to heat up 100 grams of water. So picture a little 100 grams of water, 100 milliliters of water in a beaker with a burning Big Mac under it. I want to solve for what the temperature change would be. So what I want to do is I want to get delta T by itself. So I'm going to take the energy and divide it by M and C, and we're going to solve for delta T here, the change in temp. So the energy, I'm going to pick the joules number, is 2,355,592 joules, and I'm going to divide it by the mass of water, because that's the thing that had the temp change. And I'm going to multiply it by water's constant, which is 4.18 joules per gram Celsius. When I do that, I get that the temperature change, what did I write down? It would change in temp by 5,640 degrees Celsius, which isn't even possible. It would completely vaporize all the water. Wow. Wow, log. Oh my God, I know. That's a lot. In class, we would have burned Cheetos, and I would have made a joke about flaming hot Cheetos. So, lame. Okay, next problem. How many joules? So this is, we're solving for energy, or I'm going to write E instead. To heat up 200 grams of water, 40 degrees Celsius. So here's our equation, MC delta T. The mass is 200 grams. Times the constant for water is 4.18 joules per gram Celsius, times the change in temp is 40 degrees Celsius. We're simply going to multiply all that. Grams go away, Celsius goes away, we're left with joules, and I get 33,440 joules. What's the best way to get good at this? Practice. Okay, go try it. Bye, guys.